necessary disclaimer we have to put, being in the military. So I'm in the Air Force, although I work at a Navy lab, so we'll talk a little bit about that. So there's 5 overseas DoD labs. I'm at Route 6 here in Peru. We're kind of the baby of the 5 overseas labs. So, and this is constantly changing. You see that we're named Route 6, but there's not a 1 or a 4 or a 5. And this is because we're in places like Cairo, which is not always friendly to us, or Jakarta. So we've also been in Brazil in the past. We've been in Ethiopia. We're fairly stable in Peru. Peru is a nice place to work. It's a developing economy. Got good, smart people that we work with. So I'm very fortunate to work there. Let's see if I can get these things straight. So in fact, Jakarta closed down about 3 or 4 years ago. And so now we call it Route 2 Pacific. It's going to relocate to Singapore. We're kind of in the midst of that right now. So this advances us. Oh, so this is the unofficial slide. So one of my favorite slides. I apologize. This offends me. So we'll move on. Okay, so a little bit uncomfortable there. Okay, so we're going to cover 8 main arbovirology questions. What is an arbovirus? What is a virus? How are these things transmitted? What are some of the symptoms? How are they classified? I'll use 4 different viruses to kind of communicate these questions and these answers to you. But we'll talk about many more than just these 4. You can see that dengue virus is not up here. That's the next time I come up here to lecture, if I'm ever invited back after that slide. But I do a lot of work with dengue virus. That's probably the most important arbovirus in the world. But many of these are very important as well. So we'll also do a little trivia. So why is Trinidad a bad place to visit? We'll talk about that. How far pigeons can fly. Where is the nearest BSL-4 laboratory to you? When you will be disinfectioned next. Disinfectioned. And what arthropods are good to eat with butter? So, do you know the answers to any of those right now? You do?
Yep.
Which one?
The first one.
The first one. Why is Trinidad a bad place to go?
Hepatitis.
Okay. That's one of many reasons. It's not my reason. Okay, so what is an arbovirus? So I'm an infectious diseases doctor. I deal with lots of doctors, and this is kind of a misconception, even within infectious diseases doctors, what an arbovirus is. Why do they call it an arbovirus?
Arthropod-borne virus?
Yeah, so arthropod-borne virus. I think that. So arbo. Yeah, so many people don't even know that. So very good.
Not trees, right?
But what is an arthropod? It's kind of like an insect kind of thing, right?
Segmented.
Good. So you're on to it. So an arthropod has 3 things. So it's a segmented body. What else? An exoskeleton and jointed legs. Many other things too. They have very intricate lenses. But if you wanted to break it down into 3 big things: exoskeleton, which differentiates it from a worm, for example, segmented body, and jointed appendages. So there's 5 subphylums, arthro, jointed, 5 feet. So the trilobites, which don't exist anymore. The chelicerates, which are spiders. Myriapods, like centipedes, millipedes. So hexapods, which are your insects, everything from butterflies to mosquitoes to ticks. And crustaceans. So good to eat with butter. Okay. So what is an arbovirus? So we talked about this. We talked about what is an arthropod. But let's back up. What is a virus? Kind of an easy question, but I give this lecture to ID-oriented people all the time, and I rarely get all 4 things that are usually used in the definition of what a virus is. Can anybody offer one?
Fails to self-replicate.
Good. That's one. Very good. It's not my first one, so we can't go on to my first one. Anything else? And not necessarily just you. Anybody else?
Contains genetic materials, RNA or DNA that can be replicated by another organism.
Perfect. So DNA or RNA, but not both. That's also not my first. You're not working with me. They're very small. Very small. So most smaller than 200 nanometers. So the pox virus is actually a big one. It kind of blows. Well, we'll get into something that's even bigger than the pox virus. So either DNA or RNA, not both. And when I was in medical school, we had to memorize all the double-stranded, single-stranded DNA and RNA, and I never really did that until I became a virologist 3 years ago. So laxin-dependent metabolism. So you often see in the literature HIV invades or rabies virus destroys, but really that's not true. You shouldn't attach a verb to these viruses. And there's some editors that will actually kind of nab you on that. And then replicates only within cells or organoids. Or maybe this one, did you say 3 or 4? I forgot which one you said, but you kind of meshed them together maybe. So you need a host to replicate into a virus. So this is an example of a virus that does that. And so it enters a cell through the CXCR4 or CCR5. Does anybody know which viruses would be and then it replicates and then puts off these variants. So this is one of the world's most important viruses. Not an arbovirus though. So that's HIV. Okay, so 4 things that define what a virus is, except it's not completely true. So this Nini virus kind of blows this all out of the water. Because not only is it huge, it's 800 nanometers, but it also has both DNA and RNA. So forget everything you've learned. But let's note that this is not an arbovirus. But it just shows that it's hard to make these definitions. The target is moving. Okay. So what is an arbovirus? This is the only slide I'll read word for word. Are viruses that are maintained in nature principally or to an important extent through biological transmission using susceptible vertebrate hosts by hematophagous arthropods or through transovarian and possible venereal transmission in arthropods. The viruses multiply and produce viremia in the vertebrates, multiply in the tissues of arthropods, and are passed on to new vertebrates by the bites of arthropods after a period of extrinsic incubation. So that's our definition from the WHO. So what's special about an arbovirus? So most are single-stranded RNA viruses. So a couple exceptions which we won't talk about. So this is the Reovirus, which is this causes Colorado tick fever. So that's a double-stranded RNA. And then there's one DNA virus which causes disease in pigs. So most require a host, the most common being a bird, and most require a vector, the most common being a mosquito. Okay, so besides mosquitoes, or specifically what kind of mosquitoes carry arboviruses? Aedes. Oh, and when you say Aedes, are there multiple flavors of Aedes?
Yeah, there are
Egypti, perfect.
And Culex.
And I think Albopictus. Yep.
And Culex.
Culex. Great. Yeah, perfect. So you got most of them already. And so the hemogogus, let's find then. Yeah, so the hemogogus, I wouldn't expect anybody to know what that causes here. But it causes myaro fever, which is actually one of my research interests, but it's an Amazonian viral disease. It's also kind of an alternate vector for yellow fever. But you nailed Culex with West Nile. Albopictus does a lot of things to West Nile. Albopictus is famous for doing chikungunya, which we'll talk about. And then Aedes aegypti is the classic vector for dengue. So besides mosquitoes, what else carries arboviruses? Ticks. Okay. Great. See, now we're on sync. We're going in order. Okay, so we got Ixodes and we got Thermocenter. And you know the diseases that these ticks cause. So tick-borne encephalitis for the top 2. And then this is your Colorado tick fever. And then for extra bonus points, there's 2 more classic arthropod vectors. Anyone? Viewer? Nobody? So, sandflies. So, and these carry which virus?
Niacin?
Which virus?
Oh.
You're right, though.
No idea.
Yep. You'll pick yourself that.
Oh, leishmania?
That's parasite.
It's a bit of a joke.
The sandfly fever virus. And then super extra bonus credit, midges, culicoides, scientific name, and these carry Arboviruses. Okay, so some random trivia about these arthropod, or these vectors, these mosquitoes. How far do you think they fly? Actually, not too far. And so this is another one of our research interests, is what's transmitting disease across a city, or from city to city. And it's not a mosquito flying from city to city, because they have very restricted flight ranges. Now, so yeah, less than a half mile, in contrast to Ceratotus, which can fly up to 10 miles or so. Okay, and just a couple other important things to know about these vectors is when they bite, when you're at rest. So I'll bring down this important word that you'll see a lot, crepuscular, that's dawn and dusk. So anybody know about 80s, when that usually bites?
During the day.
Right. That's during the day. And albopictus as well. And this is important because a lot of places will have both malaria as well as dengue. And malaria is usually the opposite. So lots of places you're not safe ever. So the vector that spreads malaria is Anopheles. So here's Haemophobus. So Culex is a little bit reversed. And Culicoides. So any questions up to this point? We'll talk a little bit now about Arboviruses. So you may not have heard of Culicoides or midges, but you may have heard of no-see-ums. And no-see-ums are everywhere in the world. There's only 2 places in the world where you don't find these biting midges. One's New Zealand, one's Antarctica. They love human blood. I remember playing a tennis tournament in South Carolina, and they attacked all of us. About 4 o'clock in the afternoon. They pretty much shut down the tournament. So in the Amazon, they like these felled banana trees and cocoa bean husks. And so these midges are the vector that carries Arboviruses virus. So let's talk a little bit about bunyaviruses. So Arboviruses virus is a bunyavirus. These can fall into 5 different genera. We've got the hantaviruses, which you may have heard about in Yosemite this year, which does not have an insect vector. Flevoviruses we'll talk a little bit about coming up. We'll talk about bunyaviruses as well. Okay, so why do you not want to go to Trinidad? Because this is where all these arboviruses are found. This is interesting. So this is the first account of Arboviruses virus back in 1961, so 50 years ago. You see somebody coming in. This was probably a malaria surveillance project. The fever, backache, and cough. So they took this person's blood, and back 50 years ago, they didn't have all the fancy molecular diagnostics that we have today. And they passed it through a bacteria-tight filter. And so they put it into a mouse, they kill a mouse, they take it out of the mouse, they put it through a filter, they put it into another mouse. Fortunately, we don't have to do this in my lab. So Arboviruses, explosive epidemics. Some say it's the second most important arbovirus in Brazil after dengue. It's been spread by laboratory aerosol. This has not been an issue where I work, but it's considered a BSL-3 agent. We'll talk about that later. So there's very few clinical descriptions. These are the 2 best that I could find. There's probably only about 10 papers that go into the clinical spectrum of this disease. But you can see it's kind of very nebulous. So you got headaches, myalgias, chills. A very high attack rate. So 30% of the people in any given place will get this during the big epidemics. So unknown what the host is. Some think it's this sloth native to the Amazon. And we pick this up a few times every year in our surveillance. So Ernesto mentioned I do some febrile surveillance, and we've got all these outposts throughout South America. In fact, we're moving into Colombia soon. And people can come in with a fever. When they come in with a fever, we take their blood, we take the history and physical, we take them back in 2 weeks, we take another sample, ask how they're doing. And about once or twice a year, we get orange from that blood. In fact, this shows some of the arboviruses that we collected over about an 8-year period. And so this is Oropouche, and you can see that there's about 80 confirmed, and then another 100 or so that may have been. So it's just like an IgM, just like one IgM ready to be confirmed. Okay, so Oropouche is kind of a little known arbovirus, but we'll move into some greater known ones now. So let's talk about how can arboviruses be classified. Anybody? There's kind of 3 big ways that I see it in the literature how arboviruses are classified. Anybody want to hazard a guess?
The specific vector.
By vector, thank you. Yep, so we talked about that already. By vector.
Genetic material.
What do you mean by that?
Positive, negative strand.
Yeah, but they're all kind of the same.
And then from there, they break it down into what the genes look like,
Perfect.
the arrangement of the genes.
Okay, so I think I know where you're going. Family, that sort of thing, right? Right, so either by vector, often you'll see it by clinical manifestation as well, or by family and genus. But let's talk about family and genus. So there's really 3 big families in genera that are responsible for arboviruses. But the most important one by far is the Reovirus. So you've got dengue, you've got Japanese bee encephalitis, you've got yellow fever, you've got West Nile. You've got this right here, Russian spring summer encephalitis, which is actually tick-borne encephalitis, as is this. But also you have your Viridae, and this is alpha viruses, if you take it out to the genus, and then one Reoviridae, cholera, tick fever. Okay, so we kind of have hit on this. Flaviviruses are all over the world. You don't have yellow fever in certain places, but then you have Japanese encephalitis in other places. So it is a significant problem wherever you go. But let's talk a little bit about West Nile virus. And we'll also answer one of our next questions. How do viruses emerge? So I don't know if anybody here reads New England Journal of Medicine a lot, but about once a year they come up with a very interesting paper like this. So this was last year. And they talk about this new virus, and I actually know some of the people who helped name this virus. It's probably the world's worst named virus. And I have to look it up every time. It's severe fever and thrombocytopenia syndrome virus. It's not too catchy, but I guess it's fairly descriptive. So this actually was the cause of lots of mortality, lots of morbidity in China. And they traced it back to some ticks. And it has like a 30 to 50% mortality. So this is pretty significant. And it's pretty widespread as well. But just a few weeks ago, so that was a bunya virus. This is also a bunya virus. This just came out, I think, in late September. This is the Heartland virus. So this is a flevovirus, kind of under the Bunyaviridae family. And this was in just 2 patients. Still a New England Journal of Medicine article. One was a farmer who says he gets bit by like 30 ticks every week. And so they traced this back to ticks too, not surprisingly. So some similar manifestations, some thrombocytopenia and leukopenia, some liver symptoms or some liver manifestations in one of these. Fever, obviously. This, as you can tell here in the phylogenetics, it's very similar to what was discovered in China last year, but different. But different. So are these things emerging? Maybe, maybe not, or maybe we're just getting better at locating them. But this kind of shows where some of these discoveries, or where these things have been re-emerging recently. So this is why viruses emerge. But there won't be a test on this. So, but you see this a lot. You see rho, the basic reproduction number. And if you just think about it, things on the numerator kind of help it to be high, help it to emerge. Things in the denominator work against you. So a higher vector-host ratio, a higher probability of transmission vector to host. So all these things are up top here. The extrinsic incubation rate. And then things on in the denominator, the host rate of loss of infectivity or the daily mortality rate actually work against spread of a disease or transmission of a disease. But let's talk a little bit about West Nile. Because 70 years ago, it really wasn't a big deal. So, as the name implies, it was first discovered in Uganda in about 1940 in the American Journal of Tropical Medicine, before it was Tropical Medicine and Hygiene. And it was west of the Nile. And I really enjoy going back and reading the first articles for all these viruses were named or discovered, because you read some interesting things. Let's see if this talks about it a little bit. So she came in, she was sick, but then she had denied feeling ill. And then she came back later on, and she was not altogether cooperative. And it is possible that she withheld pertinent facts. It's like, this is stuff we could never put in manuscript in this day and age. But it is kind of funny to read. So they took her blood, they injected it into a mouse, then they re-isolated it, put it into another mouse. They did this 53 times. And killed the mice every time that they passed it. So they named it West Nile virus for where this first lady had this disease. So really not a lot happened over the next 15 or 20 years. Some very benign disease. You could tell that in the 1950s it was found in Israel, but people really didn't get that sick with it. And just to go over what these people had, this is a lot like Oropouche. Fever, headache, muscle pain, fatigue. So very non-specific symptoms. And so we're comparing this to Oropouche. This is one of the diseases I'm studying, myro, and they're all very similar. You can't just look at somebody and say you have myro, or Oropouche, or dengue for that matter, or leptospirosis, or rickettsia. They're all very similar the way they present. Okay, so this is a busy slide, but this just shows that in Europe, they kind of have this low level of activity in humans, but also in other animals of West Nile. But it really wasn't severe disease from 1950 up until about 1997 or so, 1996. But then, in 1996, Romania got hit with a severe form of West Nile disease, so encephalitis. So this was written up in the Lancet. And let's just talk a little bit about how West Nile manifests. So of 100 people that get infected with West Nile virus, 80 go asymptomatic. And this is a big deal, though, because even though you're asymptomatic, you can still spread it if you, for example, donate blood, if you donate organs, and this was found in the U.S. multiple times. But let's say you're not in the lucky 80%, you're in that 20%. Most people just have a fever, but 1 out of 20 actually go on to have neuroinvasive disease. And this can be broken down into 3 different manifestations: meningitis, encephalitis, and then this polio-like syndrome. So meningitis and encephalitis kind of happen with equal frequencies. Meningitis, you have your stiff neck, you've got your headache, photophobia. Encephalitis, you have some of those symptoms, but you also have altered mental status. Usually you have a normal MRI with encephalitis, but sometimes you can have these changes in the thalamus. And then the dreaded disease is this acute flaccid paralysis, which can be confused with polio, although we don't have polio in the U.S. anymore. And so it's often asymmetric. Often people have to be put on ventilators. Even if they can be extubated, they often will have trouble breathing afterwards. They'll have to be put on supplemental oxygen or have BiPAP or CPAP, ways to kind of help them oxygenate better. So this is a severe, severe disease. But let's trace it. Let's trace it after Romania. So it ends up in Russia a couple of years after that. And then Israel, and then the U.S. So why did West Nile virus emerge in the U.S.? There were a lot of theories about this at the time. Does anybody have a theory? Yes.
Wasn't it the Gambian rats and the exotic pet trade?
You're thinking of monkeypox.
Oh, yeah.
So how did it get there, or why did it expand once it got there?
The first. There are about 4 or 5 theories.
The New York Zoo one.
Okay. Yeah. So you're like on number 4. You guys aren't working with me. So number 1, just a viremic human traveler. Somebody from Israel got onto a plane and brought it all over the U.S. I wouldn't write this down though, because although this looked convincing at the time, if you look at the phylogenetics, and it's almost the exact same virus, if not the exact same virus. Humans are dead end hosts, and they usually have low titer viremia. So that was not the reason why. So how about an infected migratory bird? That's a possibility. Except usually birds migrate from north to south, right? Except for Billy. So this was interesting. So if you read about Billy, Billy was released in France by one of these birder kind of people. And he was tagged, but he never came back to his owner. And then like a month or 2 later, another birder in New York discovers Billy, figures out that, oh my gosh, this bird is actually from France, or maybe it was from England. From France, okay. Puts him on a British Airways plane back over to Europe. So Billy actually kind of burst that whole bubble about birds not being able to fly over the Atlantic. Nevertheless, I don't think it was Billy that spread West Nile virus. But why not an infected mosquito? This has happened before, and it happens with malaria periodically. And we often call this airport malaria. When somebody brings back a mosquito, or when a plane brings a mosquito. And there's many famous cases in the U.S., and this happened about 10 years ago. There's like a 19-year-old and a 15-year-old who didn't live close to each other, but they both lived within 15 kilometers of the airport. And one came down with his fever and went to his doctor, and the doctor started azithromycin, that didn't work. Then I started levaquin, that didn't work. And then somebody in the lab noticed on the CBC, oh my gosh, there's malaria parasites here. So they actually caught that way for the 15-year-old. The 19-year-old, and I don't know how they did this, because neither of these people had ever left the country. This 19-year-old, the doctor actually thought malaria and went for malaria, which to me sounds highly improbable as an ID doctor. We ask people, have you ever left the country? If they say no, we don't check malaria smears. But it was checked on this guy. So both of these people ended up having P. vivax, which is fortunate because if it was falciparum, they both probably would have been dead, because that can kill you very quickly. And then there were some investigations that went on, and they found mosquitoes in the area that harbored this parasite. And you hear these stories periodically in the news about malaria coming to the U.S. and other places too. So has anybody been on a plane where they go down the aisle and they go tss? So that's what it's called, or disinfection is what that is called. And this is not a very regulated practice, but you can tell that they do this in some countries, and they do it in Peru too. I think they do it when we go to Iquitos, or maybe it's when you come back to Iquitos. They don't do it in the U.S. though. Does anybody know what they spray?
It's a pyrethroid, isn't it?
Very good. Very good. So it's a pyrethroid. So it comes from the chrysanthemum flower. You probably heard of permethrin. Permethrin you can treat your clothes with. It withstands about 20 washes. Keeps the mosquitoes away. So that's what they're spraying when they go up and down the aisles. Pretty harmless, we all thought. Except for this woman, unfortunately, who had some sort of allergic reaction to it. And initially she didn't attribute it to the permethrin, but then it happened again when she was on a plane and she put all the pieces together. Okay, so a couple other possibilities, things that were thrown out. Maybe West Nile was intentionally released here, nobody has ever proven that. Or maybe it was a viremic animal imported from abroad. So all possibilities. So let's trace that we were in the U.S. on the previous slide. Then it ends up in the Caribbean, in Cuba, and the Cayman Islands. You can tell it infects not only humans, but also animals. And so there's a long list. There's a long list of mosquitoes, there's a long list of birds, a long list of mammals and reptiles that can get infected with West Nile. But what's important to know is that the most important hosts are birds. And most mammals, and not all animals, are dead-end hosts. And they just get incidental infection, including humans. And this is, who's that? Who's that? That's Ernesto. Sorry, Ernesto. Okay, so tracing it down, we were in Cuba and the Cayman Islands, now it's in Uruguay, 2004, Argentina. We're still waiting in Peru for West Nile. It hasn't come yet. And as most people know here, you've been keeping up with the U.S. news, which I had trouble doing down in Peru. But this has been the worst year since 2003 for West Nile virus in the U.S. So 48 states, pretty much every continental U.S. state, more than 4,000 cases, lots of neuroinvasive disease. So probably a lot more cases that just are going unreported. 168 deaths. Yes?
How much is this clustering driven by vector density, do you think? What are the primary vectors?
That's probably why. There's probably climactic reasons that are driving this. But that's one of the big questions in all of these, and arbovirology is why do we have outbreaks certain times of the year, certain years versus other years? It's not well known to dengue. I think dengue is more studied than any other arbovirus for this. So is there a treatment? No. Is there a vaccine? Not really. As part of a treatment trial, this one right here, that's pretty much a failure. There's a vaccine for horses that is employed, but none for humans currently. Okay, so do arboviruses cause certain classic manifestations? And we talked about how we can group arboviruses by vector, by family. This is the other way that arboviruses are often classified. So the answer is yes. So what are some of those classic manifestations? There's kind of three big ones.
Encephalitis.
Good, so that's one, encephalitis.
Hemorrhagic fever.
Hemorrhagic fevers. And then the third one, you all heard of chikungunya. Chikungunya has a classic manifestation, which I think is the worst of all of them. And we'll talk about that coming up. Okay, so we got encephalitis, hemorrhage. So they all have fever, naturally. But encephalitis, hemorrhage, and arthritis. And this is a terrible arthritis. I mean, these are all bad things, don't get me wrong. But the arthritis can be terrible with these diseases. And this is just Eric's way of representing this. And a lot of these they kind of straddle one or two or three. My RO is sometimes classified as hemorrhagic, usually not though. So let's talk a little bit about chikungunya. Because if you've not heard about chikungunya, this is a fascinating disease, and it's a scary disease too. So chikungunya in Makonde, which is similar to Swahili, means that which bends or to walk bent over. And that's what you feel like. You feel like bending over, and you're in severe pain when you have chikungunya. It's an alpha virus spread by Aedes mosquitoes. And pretty much before 2004, this was just a trivia question. I took my ID boards in 2004 and never heard of this word, this virus. But in 2004, things started to get ugly with chikungunya, and I'll show you how. So this is the Indian Ocean with some of the islands. This is Lamu, which is an island off of Kenya. And in July 2004, they thought they had lots of malaria cases, but they were all malaria smear negative. And by the end of this epidemic, this outbreak, more than 13,000 people were infected. So 3/4 of the island, can you think about that? 3/4 of the island came down with this disease. So nobody was safe. And what kind of disease did they have? So after an incubation period of 2 days to 2 weeks, they had a lot of the same things that we've been talking about before: malaise, fever, headache, but also joint pain, terrible joint pain. Often this joint pain would keep people from going to work. But really no classic lab abnormalities. Once again, you really couldn't point at somebody and say you had chikungunya. except for the fact that everybody else on the island had it. So there's also a skin rash associated with this, and this is not uncommon with a lot of the arboviruses. We see it with dengue as well. So and it kind of manifests different ways. In kids, you can see these bullous lesions, whereas you'll see a maculopapular, more irrefeminous lesion in some of the adults. And then some strange manifestations like hyperpigmentation. Okay, so we're in Lamu first, now we're in Cameroon. And so they didn't suspect malaria, they suspected dengue. But all of the tests were negative. By the end of the outbreak, more than 200,000 people had this. 63% attack rate. These are just incredible numbers when you think about it. And it kept almost 80% of the people home were hospitalized. So we talked a little bit about the joint manifestations. So usually it was the smaller joints, either the hands or the feet, but it really could be any joints, and often people would just show up with arthralgias all over the body. You can see how swollen some of these joints look. Okay, so now we jump to La Reunion. So now 40,000 cases a week, almost 250,000 cases. And this is a big deal. This almost got no press back in 2004, 2005. You can see some pictures from the hospital. This would just overwhelm the local public health and hospitals. And it was here on this island that it was discovered that not only Aedes aegypti, but also albopictus can spread this disease. And why is that important? Does anybody know kind of the difference between these two mosquitoes? So we talked about aegypti. That's the main mosquito for dengue. But for albopictus, it actually has a broader range of hosts. It can overwinter, so that means it kind of stays with the eggs over the winter, so it can kind of stay in the same place, even though it gets very, very cold. And it has different places that it can habitat, not just paradomestic, but also kind of the natural jungle settings. Because if you know anything about dengue, this is mostly an urban disease. Dengue is mostly an urban disease. Yes?
Aedes albopictus is also quite new to the Americas, or just new, you know?
Oh, yeah, well, that's a good point, actually. It's not that new to the Americas, but it does have a broader geographical range, and I'm glad you brought that up. So it gets all the way up here in North Carolina, which I guess aegypti does too, kind of. But so this is a scary one, and I actually sat on the committee that prepared this in response for chikungunya virus in the introduction to the Americas. Hasn't come yet. There were a few cases in Brazil, but I think they were all travel associated, I think. So it hasn't come yet.
Have there been R0 estimates for chikungunya in the U.S.?
Probably. I'm not aware of that. But, gosh, we make a big deal about 15 cases or 15 deaths from meningitis from this big thing in the press right now. Could you imagine chikungunya coming and how it can infect 60 to 75% of the population and keep them from working? It could happen. So we can see how this spread throughout the Indian Ocean, Mauritius, Seychelles, Madagascar, the Maldives. So, and then the chronic symptoms, and I think this is probably an underestimate with some of the arbovirologists that I've talked to, but up to and maybe more than 10% of the people still have symptoms at 3 to 5 years. And not only joint symptoms, but also depression and fatigue. Which brings me to another one of the projects that we're doing at Number 6. So Ernesto talked a little bit about our febrile surveillance, where we see people when they're acutely sick, and then we have them come back usually about at 2 weeks. But probably my favorite project is where we follow people with arboviral infections, not only at the convalescent or the 2-week period, but also 3 months, 6 months, 12 months, 24 months. And we're following dengue, we're following myaro, oropouche, we follow chikungunya if we had it. It's really a fascinating study, and we're uncovering very interesting things. The hard part about it, it's expensive to do, because people don't like to come back in 3 months if they're feeling well. They don't even like to come back in 2 weeks if they're feeling well. We have probably 50 to 65% of the people, 50 to 75% of the people show up here we got to hunt them down at 3, 6, and 12 months, usually. And this is one of the impetuses or impeti of why we're doing this, the West Nile virus long-term prognosis studies. So we're just doing the same thing, but for our own arboviruses in South America. So as I said, we have to find these people often. And it means we often, here's me in the back, we often have to get on a bus, or not on a bus, we have to get on a boat. This is on the Amazon. Go to somebody's house, have to take off our shoes, roll up our pants, and then we collect blood, we collect urine, we do all the vital signs, ask people how they're doing. It's really, it's a lot of fun. But we're finding that people are still sick with myorovirus, which is an alpha virus similar to chikungunya, at 6 months and 9 months and 12 months. So we were in the Indian Ocean, now we're in India. So 1.3 million cases in 2006. And so this is not just a skin problem, this is not just a joint problem, there are also neurological issues, there's some renal issues, there's kind of some oddball issues, more severe, more common in older people than younger people. And then Italy reported a lot of cases. And so most of the Italians had traveled to one of these high-risk islands. But there was also some autochthonous cases, so people who had not traveled. So the virus actually kind of set up shop in that area, at least for a season. So there's some local transmission going on. And so just over the last 12 to 18 months, this is still going on in the Indian Ocean as well as other places throughout Asia. And we're just waiting. It could come to the Americas at some point. Okay, so some other important facts about chikungunya. There's no antiviral or vaccine available. It can be transmitted from mother to infant in the womb. There's treatment is just supportive. And increasing reports of travelers. Many reports in U.S. and Canadian travelers, more than 100. Okay, so this is my last virus, and I think probably my last question. So how are arboviruses diagnosed? We have a big lab down in Peru, and we kind of do this. There's 3 main ways that we diagnose arbovirus infection. Anybody want to hazard a guess as to what would be one of those ways? If Ernesto set up, he thinks he has an arbovirus infection, and you were his doctor, what would you do with his blood?
PCR.
Mm-hmm. Right, so there's molecular methods, serological, and culture. Right. And that's essentially what this is saying. And so that doesn't only hold for West Nile or chikungunya, that's kind of how we approach almost all arboviruses. And this is from, I think, the West Nile treatment and diagnosis guidelines. So 4-fold rise in titer, isolation or genomic sequences. At least for West Nile, you can also do an IgM on the cerebrospinal fluid. And then less ideal is just one IgM. But as I said, sometimes people don't show up in their second one. So we call these confirmed cases, and we call these more presumed in my laboratory. Everybody has their own way of clustering these up together. Some words of caution, a lot of the flaviviruses cross-react, and some of the alpha viruses do as well. So you have to do very specific serology tests, like neutralization tests. So let's talk about VEE, or VEEV, which is an alpha virus. And we've already talked about chikungunya, which is an alpha virus, and myara, which is also an alpha virus. So chikungunya and myara are in this Semliki forest complex, which causes these arthritides, whereas the encephalidides are down here. So VEE would be one of them. And so these are some of the main alpha viruses to worry about. And you can see it's either encephalitis or arthritic for the most part. And how do you remember which are alpha viruses and which aren't? Alpha viruses are usually abbreviated. So VE, alphabet, VE, WE, triple E, and then some really strange words, like chikungunya and yang. Those are your alpha viruses. I don't know if that works for you or not, but if you want to memorize your alpha viruses, that's how I would do it. So VEE, this is actually a virus that shows up in outbreaks often. We get about 1 or 2 cases every year. We're waiting for the next outbreak to happen. We're kind of poised to be the ones that will diagnose and follow it. The last big one was about 15 years ago in Venezuela and Colombia. 2 countries actually where we're setting up surveillance sites over the next few months, where 100,000 people were infected. And it's not just the people that get infected, it's also the horses as well. So what happens to the people? Most people are symptomatic. Once again, you kind of see your classic arboviral symptoms: headache, fever, fatigue, chills, myalgias, people dragging out for weeks. And this may recur. Horses don't do so well. So after an incubation period, they initially feel a little depressed. But in most, they get encephalitis, and this can wipe out herds and herds of horses. And that's what happened in Venezuela in the last outbreak. So they go into this circling ataxia and hyperexcitability, and then death. So let's talk a little bit about diagnosing arboviruses, because we do a lot of that in my laboratory down in Lima, Peru. And so you have the things that give you the most confidence: viral isolation. There's nothing like having a virus in your hand. It's even better than having molecular material in your hand. But unfortunately, these are more expensive tests and less accessible. Although we have them all in my lab, so we often do all the kind of the main ones. We do this, and we do this. So let's talk a little bit about isolation or culture. There's a word we use a lot called CPE, cytopathic effect. And so what we do is we'll take Ernesto's blood when he comes back from the jungle. We'll put it onto these cultures, these cell cultures, and if we see the cells die, we'll say, hey, Ernesto's got something nasty in his blood that's killing these cells. After that, we take these radio-labeled or these isotopically labeled or fluorescently labeled antibodies, and they light up if they're positive. So we call that IFA, immunofluorescence, positive or negative. And just of interest, this is not always a benign procedure. People can actually get sick in the isolation lab. And it happened in our lab about 10 years ago before I was there, where somebody actually came down with VEE because she inhaled this VEE. And you can see some of the other viruses to wash out from the lab, many beginning with H. But you even have Ebola and Marburg, rabies. And people have been known to die of VEE that have worked in the lab. And so we often talk about BSL-4 and BSL-3. There's a whole book, a whole manual that goes through every virus that can cause disease or may cause disease, and kind of ranks what level each one justifies. And it's a long, long list. So I just copied one of the pages, and you can see VEE right here. I think that's the only 3 on the page. And then there's just a handful of 4s. And they're all, or most of them are hemorrhagic fever agents. And it's very strange today. I was jogging before I came in, and I listened to this podcast. It's This Week in Virology. And they were actually, so they asked this question about what are the 4 families or genera that can cause viral hemorrhagic fever. I'm like, oh my gosh, that's going to be my lecture today. So it's a great podcast if anybody's interested. They do it every week. It's an hour long. So I wanted to call in and answer it, but it was a podcast. So does anybody know? Could anybody answer that question, or at least one of the 4?
Flavivirus?
What do you say?
Flavivirus?
Perfect. So flavivirus is like dengue.
Filovirus?
Filovirus is like Ebola and Marburg. Great. So the other 2 are maybe a little bit more challenging. Arenaviruses, and I forgot who's the med students in here, but these are the viruses: the Bolivian hemorrhagic fever, Brazilian hemorrhagic fever, and there's an Argentine hemorrhagic fever, and I could never keep these things straight when I was a med student, but those are all arenaviruses. And then there's the Crimean Congo hemorrhagic fever, which is a viral virus. So this is a partial list, but these are some of the most important BSL-4 agents. What does BSL-4 mean? It means if you know it exists, you should take a lot of precautions. And let me show you which precautions. We have a BSL-3 lab where I work, and there's not a lot of places that have BSL-3 labs. There's even fewer BSL-4 labs. So if you look at BSL-4, you need controlled access, so that means you have to do like your little fingerprint or do a retina scan. You have to do a serum sample before you ever start working there. The full moon suit, bodysuit, shower before and after. And so you can just see that the precautions get greater and greater as you go from 1 to 2 to 3 to 4. And so what's the closest BSL-4 laboratory to Durham? I think that was one of our trivia questions. Probably Richmond, I would guess. This is a little bit dated. This is about 5 years old. I've been very fortunate. I just got a tour of the one in Galveston, and they have a very nice BSL-4 lab. And I've gotten a tour of the CDC one as well. And I'm trying to get myself into Frederick since I am in the military. This is the military's BSL-4 laboratory. But, a lot of interesting research going on, but it's very restricted in the United States, and not that many places overseas, as you can tell as well. Okay, so we do some other serology. We do IgM. I'll talk a little bit about plaque reduction neutralization testing. Anybody familiar with this? We probably do more PRNTs than almost any lab in the world, and this takes advantage of whether you have antibody in your body or not, but it's very, very specific. And in fact, it's the only way that I could take Ernesto's blood and say that you had dengue 1 or 2 or 3 or 4. Otherwise, I could just say you had dengue. And so it's very specific. It also is very specific in differentiating between the different flaving viruses. So let's say Ernesto has had dengue, and let's say Brian has not had dengue. So Ernesto is going to have antibodies to dengue 2 in his blood, whereas Brian would not. You both would give your blood to me. I have virus in my refrigerator and my freezer, and if I just put that virus on the cell culture, it's going to cause these plaques. And if I have Brian's blood, there's no antibody binding up the virus that I pulled out of my freezer. But if I have Ernesto's blood, and we're going to say that Ernesto's had dengue too, then it will bind up the virus, and then we won't see any plaques. So it's reducing the plaques. And this is what it looks like. So you can see that this person, it's a little counterintuitive, but this person would have had whatever disease that we were testing for. As you can see, they don't have any plaques. Does that make sense? And then it's really a brave new world for molecular techniques. And we're just exploding with what we're doing in my laboratory. And you can just tell over the last 15 years how this has really taken off. The completed genomes, just 10 years ago, what is this, like 10? And I bet this is if it's not over 1,000, it's going to soon be over 1,000 very quickly. And we're doing a lot of this for pathogen discovery. So we're getting these people coming in from the Amazon with a fever. Our IFAs, our immunofluorescence, our culture, our serologies are all negative. So we have to rely on molecular methods. And we'll amplify often unique genomic sequences. In fact, over the last 2 years, we've identified and named 6 new viruses. 3 of these have been published, or 4 of these have been published now, and 2 are in review, including, this is an electron microscope of the Iquitos virus. So we usually name it after the place where we found it.
What's Maldonado?
Maldonado, yes, that's where Beth works.
What's that virus?
It's a bunion virus. We can talk more about that. There's no vaccine though. So. And we often do these things in collaboration with our partners, often who have BSL-4 labs, as you can tell right here. I think that's my last slide. Here's another funny medical student differentiation slide. And look, 12:59. Okay. But if you have any questions, please ask. Yes.
So this is a bit of a tangent, but and I don't know anything about it, but do the nature of the arboviruses we talked about make them more or less likely to be candidates for vaccine development or easy vaccine development? I don't know much about what makes a virus easier or harder to develop a vaccine for, except.
Yeah, that's a tricky question. because there are some vaccines for arboviruses. There's a Japanese encephalitis vaccine, there's a yellow fever vaccine. Those are two that come. There's a tick-borne encephalitis vaccine. But one of the biggest news out of virology this year is the dengue vaccine was a failure. And one of the reasons why is that there's 4 serotypes of dengue, and within those serotypes, there's different lineages and different genotypes. And a complicating factor of dengue fever is if you get infected on your second time, it can be worse than your first time. So if I vaccinate Brian and I vaccinate him against dengue 1, I may be setting him up for worse disease if I can't vaccinate him against 2, 3, and 4. So you got to hit a grand slam with the dengue vaccine. And so they all kind of have these issues going on. I don't know of a vaccine against, there is a VE vaccine as well. So, I mean, you have to look at each one in isolation. And some of these are just not worth vaccinating against. Something like Arboviruses, which makes 10 people sick every year that we know of. And there's a Lyme vaccine, a Lyme disease vaccine. And Lyme is pretty common, but it just wasn't being used enough, so it got taken off the market. So, any other, yes?
Does Arboviruses have like a somatic transmission cycle like dengue?
There's so little known about that. So they think that the host in the wild is this sloth, but there may be other insects that help transmit it. It's just very tough because Arboviruses is just considered dengue until 3 weeks later that we get the culture back. It says that's Arboviruses.
But do you think it's actively maintained in the human population, or is it like possible spillovers from the somatic cycle? That's what we want to call it.
It's probably the latter. I don't see it being maintained in the human population for very long. But that's actually one thing that we're following in our long-term follow-up studies.
I think there are a number of studies taking on. Can you talk a little bit about the implications for climate change with relation to arboviruses? I mean,
yeah, so that's a sticky one, and I'm involved in like 28 dengue studies, and that's one of them. I'm just a very tangential player on it, but I think there's always the chance that climate change may drive these epidemics, but they also may reverse them too. And I think you have to be very careful with how you set up your study design. And I don't know how you would design a study to really look at that effectively. But often I'll see that researchers who are looking into climate change and disease, they only want to answer it's causing worse disease. But I think there's an equal chance that the opposite is true too. So that's my little political spin on that. But I'm still part of some of these studies, but I often will kind of poke people and say, hey, but what about this? Well, thank you very much.